S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult science concepts made easy. Study anywhere, anytime.
Hello everyone. Welcome to the S. Chan Academy. I am Dr. Sujata Sengupta. In today's lesson, we will be learning all about the chemistry of alcohols. So, let's begin today's lesson. If you want to know more, you can refer to the books by S. Chan Publishing, the link to which is provided in the drop box below. Alcohols. What are alcohols? Alcohols are organic compounds which contain an hydroxyl group. They are some of the most common organic compounds which are found in nature, in our common household products, and widely used in the industry. The word alcohol is perhaps the oldest chemical word that exists, and it comes from the Arabic word alcool, which essentially means essence. Ethanol, also known as ethyl alcohol, is the essence of wine. It is the main ingredient in our wine or alcohols. Methanol is commonly used as a fuel and as a solvent. And isopropyl alcohol, well, we have all probably used it at some time, as it is commonly known as rubbing alcohol and is used for treating minor skin infections, cuts and wounds. Alcohols may be synthesized by a variety of methods. They are very reactive and can be converted into a wide variety of organic compounds. As a result, alcohols have extreme versatility in organic chemistry. And in today's video, I will show you how they play a central role in organic chemistry as reagents, solvents, and intermediates. So far, we know that alcohols are molecules which contain an hydroxyl group. Alcohols can be classified according to the nature of the carbon atom which is bonded to the hydroxyl group. In a primary alcohol, the carbon which is bonded to the hydroxyl group is also bonded to one other carbon atom. In a secondary alcohol, the carbon bearing the hydroxyl group is bonded to two other carbon atoms. In tertiary alcohols, this carbon is bonded to three other carbon atoms. Phenols are organic alcohols, that is, the hydroxyl group is bonded to a carbon which is present in an aromatic ring. Phenols have properties which are similar to that of alcohols and also have properties which are also characteristic of its aromatic nature. I hope you are following our videos in the S. Chan Academy, and you can always go back and watch our video on the chemistry of phenols. So how do we name our alcohols? So according to the IUPAC nomenclature, the name will carry the "ol" suffix together with the number that is given to indicate the position of the hydroxyl group. So what are the rules? First, we will identify the longest carbon chain which will contain the carbon with the hydroxyl group. We will add the suffix "ol." We will then number the position of the hydroxyl group, starting with that carbon which is nearest to the hydroxyl group. And then we will name all the other substituents. So let's do an example. So here I have a molecule for you. How do we do the nomenclature? So first we identify the longest chain. we notice it's a 4 carbon containing chain. So the root name is butanol. The group which contains the carbon on the second position contains the hydroxyl group. So it is butane 2-ol. And now finally we will add all the other substituents, and its IUPAC nomenclature is 1-bromo-3,3-dimethyl-butane 2-ol. Now certain alcohols will have common names. In the common name, the name of the alkyl group comes first, followed by the word alcohol. For example, ethyl alcohol or methyl alcohol or isopropyl alcohol. Alcohols are polar molecules. Why? Yes, because they contain a hydroxyl group. The hydroxyl hydrogen in our alcohols are strongly polarized, and it bonds with the non-bonding electrons on another alcohol, forming hydrogen bonds. As a result of this hydrogen bonding, alcohols are also soluble in water. The alcohols methanol and ethanol, they have a fruity odor, and because of this polar nature, alcohols are better solvents compared to our typical hydrocarbons. One important property of our alcohols is that the hydroxyl proton in an alcohol is weakly acidic. Now what does this mean? This means that in the presence of a strong base, the strong base is able to abstract or remove the hydroxyl proton and results in the formation of an alkoxide ion. The pKa values of alcohols are generally around 16. The presence of an electron withdrawing group in the alcohol moiety will further enhance its acidity. So, for example, 2-chloroethanol is going to be more acidic than our simple ethanol molecule. And why? Because the electron withdrawing chlorine atom is better able to stabilize the 2-chloroethoxide ion. Because of the negative charge on the alkoxides, these alkoxides are very strong nucleophiles. And so what can they do? They can attack another electrophilic carbon. So how do we prepare these alkoxides? The easiest way to prepare the alkoxide is by treating the alcohol with sodium or potassium metal, and in the process there is the liberation of hydrogen gas. In general, the primary alcohols are more easily converted into their corresponding alkoxides compared to the secondary and the tertiary alcohols. In the case of tertiary alcohols, we treat them with potassium rather than sodium to get the corresponding potassium alkoxides. Now that we've covered their nomenclature, their classification and their physical properties, so let's move on and look at some ways in how we can prepare these alcohols. Remember, alcohols can be prepared by the nucleophilic substitution of alkyl halides. If you remember, our methyl and our primary alkyl halides will undergo reaction by the SN2 mechanism, whereas our tertiary alkyl halides will undergo reaction by the SN1 mechanism. Another method for preparing our alcohols is by the addition reaction on alkenes. So if you remember that alkenes can be converted to alcohols through an acid catalyzed hydration reaction. Here the reaction is going to proceed by the Markovnikov's addition, selectivity. Other methods to prepare our alcohols include, for example, the oxymercuration or demercuration of alkenes. This also gives us alcohols, which also follows the Markovnikov selectivity. If we want to prepare alcohols with the anti-Markovnikov selectivity, then we can do so by a hydroboration oxidation reaction. Finally, when alkenes are treated with osmium tetraoxide in a cold alcoholic solution of KMnO4, then it undergoes dihydroxylation to give us 1,2-diols. So this method is an excellent method for converting alkenes into our 1,2-diols. But by far the largest and the most versatile method for the preparation of alcohols involves the nucleophilic addition to carbonyl compounds. Here you will remember that a carbonyl group is highly polarized, where the carbon bears a slight positive charge. In other words, it is electrophilic in nature. So nucleophiles therefore can add to this electrophilic carbon, and in the process the carbonyl compounds gets converted into the alcohol. So let's take a deeper look into this type of nucleophilic addition reactions. So as I had mentioned earlier, in our carbonyl compounds, this carbon-oxygen bond is highly polarized. The oxygen pulls the electrons more towards itself. It gets a slight negative charge, whereas the carbon becomes more electropositive. So now our strong nucleophile, for example, this R minus, can come and it can attack this electrophilic carbon. And when it does that, let's move my electrons. And so when it does that, it leads through the formation of an alkoxide ion. This alkoxide ion, it's a strong base, and so it can be readily protonated either with water or, for example, in a dilute acid solution, and it results in the formation of an alcohol. So via this nucleophilic addition mechanism, our carbonyl compounds are converted into alcohols. Not only that, here you can see we have also generated a new carbon-carbon bond. One of the most important things that we like to do in organic chemistry. So, in general, compounds like our Grignard's reagent, remember our organometallic reagents, Grignard's reagents are MgX. Grignard's reagents, they can add to our carbonyl compounds to form the corresponding alkoxide ions, which can then be protonated to give our alcohol. How are these Grignard's reagents prepared? Remember, the Grignard's reagents are made by addition of the magnesium metal to our alkyl halide. The reaction for the preparation of the Grignard's reagent, it takes place in anhydrous ether. So, let's consider the addition of a general Grignard's reagent to our ketone. So, I have R MgX and I have a generic ketone. Here again remember that the carbonyl carbon is electrophilic in nature. In my Grignard's reagent, magnesium is more electropositive, and so I have the alkyl group with a slight negative charge. So this can now attack the electrophilic carbon of the carbonyl group, and what happens? It results in the formation of my magnesium alkoxide salt. This magnesium alkoxide salt with reaction with water or a dilute acid solution forms a tertiary alcohol. Alright, so ketones with nucleophilic addition of the Grignard's reagents are converted to tertiary alcohols. So following the above protocol, addition of the Grignard's reagent to an aldehyde followed by protonation will give us secondary alcohols, and finally the reaction of the Grignard's reagent to ketones followed by protonation will give us the tertiary alcohols. And in each case, remember, there is the formation of a new carbon-carbon bond. Let's take a quick break, but before that, let me ask you this question. Will you be able to solve it? Can you tell me what is the product that is going to be formed when the Grignard's reagent phenyl magnesium bromide reacts with acid chloride? If you noticed, in this reaction, I have given you 2 moles of the Grignard's reagent, and that is a clue for you to identify or write the correct product.
हाय, मैं हूं नेहा शर्मा और मैं आ रही हूं एस चांद अकेडमी में आपके फिजिकल केमिस्ट्री के डिफ़िकल्ट कंसेप्ट्स को इजी बनाने। सो प्लीज़ हमारे चैनल को सब्सक्राइब करिए ताकि आप अपनी सारी फिजिकल केमिस्ट्री की प्रॉब्लम्स को भूल जाएं और सबके सॉल्यूशंस आपको मिल जाएं।
Welcome back to the S. Chand Academy. Before we went on our break, I had given you this reaction to solve. I hope you have been able to. If not, let's quickly review. So, acetyl chloride, when it reacts with 2 moles of the Grignard's reagent, our phenyl magnesium bromide, what does it form? It forms 1,1-diphenyl ethanol. So, in general, remember that acid chlorides or esters, they react with 2 equivalents of the Grignard's reagent, and they always give the tertiary alcohols. Why? Because addition of the first equivalent of our Grignard's reagent to the acid chloride converts it into a ketone. But the reaction does not stop there. This ketone will continue to react with another equivalent of our Grignard's reagent, and the final product is a tertiary alcohol. So, what do we know so far? We know that carbonyl compounds can be converted to alcohols with the help of our Grignard's reagents. But carbonyl compounds can also be converted to alcohols by using reducing agents like complex metal hydrides like sodium borohydride or lithium aluminum hydrides. The sodium borohydride is slightly more selective and it only reduces the aldehydes and the ketones, whereas lithium aluminum hydride, it is more stronger reagent and it is able to reduce aldehydes, ketones, acids and esters to the corresponding alcohols. Reducing a carbonyl compound, more specifically an aldehyde or a ketone, into an alcohol can also be accomplished by catalytic hydrogenation using Raney nickel. So, Raney nickel here is a very effective catalyst for the hydrogenation of our ketones and the aldehydes, and we get the corresponding alcohols. But here remember that even a carbon-carbon double bond is also reduced under these same conditions. So, if our molecule contains both a carbon-carbon double bond and a carbonyl moiety, then both are going to be reduced. So, that is why we generally prefer to use sodium borohydride for the reduction of our carbonyl compounds rather than catalytic hydrogenation with ranil nickel. So now let's move on and look at some of the reactions of our alcohols. Alcohols can be converted into a wide variety of different functional groups using various type of reagents. The alcohols can be converted to the alkyl halides, they can be oxidized to the carbonyl compounds, and they react with carboxylic acids to form esters. Alcohols can be converted into the halides by using a wide variety of reagents. So, for example, we can use the corresponding hydrogen halides, we can use phosphorus tribromide, or we can even use thionyl chloride. Remember, this reaction again is another example of a nucleophilic substitution reaction, which we had discussed before in our previous videos in the S. Chand Academy. So, do go back and revise. So, generally what happens, remember that our primary alcohols tend to react by the SN2 mechanism, whereas the tertiary alcohols tend to react by the SN1 mechanism. Addition of phosphorus tribromide will also convert the alcohols into the corresponding alkyl bromides. Dehydration of alcohols using strong acid catalysts like phosphoric acid results in an elimination of a molecule of water, also known as dehydration, and results in the formation of an alkene. Here we follow the Zaitse's rule to prepare the more substituted alkene. Esters, we know, are one of the most common acid derivatives. How are esters produced? Esters are commonly produced by the Fischer esterification reaction. Here what happens that the alcohol is treated with an acid in the presence of an acid catalyst. Esters can also be prepared by treating our alcohol with acid chlorides. Alcohols can be oxidized into a variety of carbonyl compounds depending upon the nature of the alcohol and also the type of oxidizing reagent which is used. Remember, oxidation of the alcohol will involve the loss of the proton in the hydroxyl group along with the loss of a proton on the carbon attached to this hydroxyl group. A primary alcohol will get oxidized either to the aldehyde or to the carboxylic acid depending upon the nature of this oxidizing reagent. Secondary alcohols get oxidized to the ketone and tertiary alcohols are not oxidized at all, no matter which reagent we use. Mild reagents will stop the oxidation of primary alcohols at the aldehyde stage. So, what type of reagents can we use? Here we can use reagents such as PCC, pyridinium chlorochromate. We can use PDC, pyridinium dichromate, and we can use the Sworn oxidation or the Des-Martin oxidation conditions. Under the same conditions, secondary alcohols get converted to the ketones. With strong oxidizing agents, primary alcohols are oxidized to the carboxylic acid. Here note that the reaction will first produce our aldehyde as an intermediate which quickly further undergoes oxidation to the carboxylic acid. secondary alcohols get oxidized to the corresponding ketones. So here you can see that aqueous acidic solutions of sodium dichromate or Jones reagent are able to oxidize ethanol into acetic acid. And finally, if we have our 1,2-diols, then oxidative cleavage of these 1,2-diols to the corresponding aldehydes and ketones using sodium periodate or periodic acid is also possible. And before we end today's lesson, let me quickly tell you about how we can distinguish between primary, secondary and tertiary alcohols. We perform what is known as the Lucas test. Here we perform this test using a solution of anhydrous zinc chloride in concentrated hydrochloric acid. Primary, secondary and tertiary alcohols will all have a difference in their reactivity towards this Lucas reagent. So basically, the primary, secondary and the tertiary alcohols will react with the Lucas reagents to form our organochloroalkanes. The tertiary alcohols reacts the fastest, whereas the primary alcohols will only react once they are heated. So, I hope you have enjoyed today's lecture and have learnt all about the chemistry of alcohols. We had discussed what are alcohols, what are its classification. We looked into various methods of their preparation and some of the key reactions in which they are converted to other important organic compounds. I hope you enjoyed this video. Please hit the like, share and subscribe button and don't forget to hit the bell icon. Thank you.